Hello, everyone. Welcome to the Unity Theater. My name is Zarrow. I work at Google. I work in partner engineering. And yesterday, you heard my boss, Phil Harrison, announce Stadia, which is cloud game streaming from Google. On Stadia, AAA games run in a Google data center and stream over the internet to gamers playing in a Chrome browser, or on their TV using a Chromecast, or on their tablet or phone. And Stadia launches this year in 2019. We also announced yesterday that Stadia will fully support Unity. I promise. There we go. Stadia will fully support Unity. If you can build a game for Unity, you can build a game that streams from the Stadia cloud. You will be able to build and deploy your game to Stadia right from the Unity editor with all of your familiar workflows and all of your familiar tools. And this is great news for me. I am excited to just be able to pop open the Unity editor instead of writing thousands of lines of Vulkan code to draw stuff on the screen. Stadia uses the Vulkan library for graphics, and I was going to talk about it today and tell you all the performance benefits. In fact, here's a list of the things I was going to talk about today. But I realized that Unity abstracts all of this away for you. So by using Unity, you avoid having to learn the Vulkan APIs if you're not already familiar with them, and same with this other stuff. So what am I here to talk about? I'm here to talk about the parts of our development platform that are relevant to you, a Unity developer, someone who works on a Unity game. Again, I'm Zach. I was the first hire onto the partner engineering team for Stadia. Before this, I worked for Xbox in ATG, where I worked on the 360 and the Xbox One. And recently, I got to help Ubisoft port Assassin's Creed Odyssey onto Project Stream, where it same-day shipped with their other platforms. And my favorite Unity game is Overcooked. My wife and I challenge anybody to Overcooked. We really like that game. So one of the first tasks when I joined this project was to fly around the world with our business development team and give technical disclosures to studios who would potentially work on our platform. We would visit a studio, hook up a Chromecast to their TV, and stream a game from whatever Google data center was closest to them. My favorite part of the job was putting a controller in the hands of a developer, a CTO, an EP, and seeing their skepticism turn into pure excitement. There's this moment, I've seen it many times, and they realize that yes, we are for real about this, cloud gaming is here. So I encourage you to try out our demos. They're over here in the South Hall. We have a booth right over there. It has the big Google logo, Stadia logo, can't miss it. And additionally, in the West Hall on the second floor, we have more demos. So you can play Assassin's Creed streaming from our cloud, and you can even try out our developer tools, which we're going to talk about in a second. Oh yeah, so try it out and see how it feels, and think about what gaming is going to look like in the 2020s. If you're interested in developing on our platform, you can go to our website, stadia.dev, and apply to become a Stadia developer. We'll be rolling out developer access throughout 2019. We expect Unity integration to be ready by the end of this year. Look, it's .dev, aren't we hip and cool? That is so hip and cool, that TLD. And this is what the site looks like. Just hit apply and fill out the form. Throughout the development of Stadia, one phrase I've heard over and over again internally is democratizing game development. Democratizing game development. Eventually, I looked it up to see what this buzzword meant. I Googled it, and if we look, Unity is all over the results. It turns out that it's one of Unity's core tenets, and it's a shared goal between our platforms. Not only to make games more accessible via a lower barrier to entry, but to make game development more accessible and to empower more developers with tooling to make great games. And working with Unity is a solid step in this direction. We look forward to combining the capabilities of our cloud streaming platform and with Unity's engine and Unity's community to make game development more accessible and more powerful for more developers. So here's what it looks like to run a Stadia game. This is our test client. It runs in Google Chrome, and it streams your game to you. It also sends input back up to the instance that your game is running on. Our platform supports gamepad, mouse, and keyboard. Any HID-compatible gamepad will work, so you can plug in your DualShock, your Xbox controller, and we're also making our own controller, which we announced yesterday. Right now, it's called the Stadia controller. It connects through Wi-Fi directly to your game instance running on the cloud. So it's sending data on Wi-Fi up to the cloud. It's not really directly interacting with the endpoint you're streaming the game on. It has a dedicated button for capturing gameplay video, and it has a Google Assistant button. Like, okay, Google, how do I beat the boss? And maybe it'll show you a video. Okay, Google, where the heck am I supposed to go? Is what I need in a lot of games. And look at this, you can't see this, but it's actually responding to me right now on my laptop, on my Chromebook. And then I'm trying to convince the studios I'm working with right now to implement cheat codes through the Google Assistant, because I think that could be fun. It's like if you say, okay, Google, I'm getting owned by this really talented developer's amazing game, then it enables God mode or whatever cheat you want. But let's say I'm testing this game in our test client. This is the Robot on the Beach game, I guess. Robot Beach Simulator 2019. I don't know. But I hit a bug, and I have no idea what I did to cause it, and I don't know what the repro steps are. If you hit that record button in the client, we have a mode where this actually works retroactively. So it starts recording 10 seconds prior to when you press the button, just like time travel. When we hit stop, it gives us a link to a video file that downloads instantly. And then we can look back and maybe we can figure out how to repro this bug we found. You also have the ability to emulate different network conditions right there in the client. Remember, users have to pass a speed test before they can play on Stadia, just like we did with Assassin's Creed on Project Stream. But this helps you understand how your game behaves if the user's network degrades as they're playing the game. In fact, you can switch these profiles in real time. So you're playing your game, you don't have to restart it, you can change the different network profiles and see what effect it has on your game. And this is our Chrome extension. I know, it's very surprising. Google built a Chrome extension for its platform. Who would have expected that? This extension surfaces real-time streaming telemetry directly in the Chrome inspector. So you pop up and open the Chrome inspector, you get a Stadia tab, and then you see a bunch of graphs. And these graphs show bitrate received over time, frame rate render time, encode time, decode time, round trip time for packets on the network, and more. So this data enables developers to zoom in on the whole stack and get the clearest picture on where any latency is occurring, and tune their game and their streamer settings appropriately. This data will also show how our streamer dynamically responds to changing network conditions over time. Our streamer analyzes the network environment that your game is running in and dynamically selects the optimal compression settings for the specific characteristics of the network. So you can use these graphs in coordination with those network emulation tools to tune your game for the cloud. So the Chrome test client is one tool we built for our platform. I could definitely imagine something similar to this surfacing directly in the Unity editor, but you'll be able to use our tools too, our third-party tools. We support familiar third-party tools that you already may be using to develop games on Unity for other platforms. So we have full integration with Visual Studio for development and debugging. We use RenderDoc for graphics debugging, and we use vTune for CPU profiling. A lot of the tools I don't have time to show. We also have Gapid for graphics debugging, as well as RGP, the Radeon Graphics Profiler. In Visual Studio, we give you what you would expect. After you install our SDK, Stadia shows up as a build platform that you can target, just like any other platform. And the Unity editor, in addition to allowing you to deploy your game directly to the cloud, it gives you the option to generate a Visual Studio solution, which you can then open and use with our tools and use with our VSI plugin. Just select Stadia as your build target and then hit F5, and our plugin will automatically deploy your new binary to the cloud, and it opens the test client that we just saw and your game launches. We have project templates, MS Build integration, and we integrate directly with and fully with the Visual Studio debugger. It attaches to your game running in the cloud. You can attach to a process that's already running. We support connecting to a symbol server. It's the same debugging you're used to in Visual Studio. For graphics debugging and profiling, our platform uses RenderDoc. When your game has artifacts, you can capture and analyze frames in here, and it's the same RenderDoc GUI that you would use on other platforms. It's automatically installed when you install our SDK, and our platform is integrated with RenderDoc's mainline on GitHub. It's open source, and we're synced to main when we release that. And then for CPU profiling, we support vTune Amplifier. That's a tool made by Intel. And vTune gives you data visualizations of where your CPU time is going, how your cores are behaving. And we have hands-on demos of these live on the show floor. Again, in our Google booth down here in the South Hall, and also on the second floor of the West Hall. You can try out these tools on the cloud. So before I get into more details about our stack, how Stadia development works, let's talk specifically about Unity and Stadia and what the integration will mean for Unity developers. On Unity, Stadia is an IL to CPP platform, meaning that you need to build your scripts using IL2CP, the scripting backend, as opposed to Mono. IL2CPP stands for Intermediate Language to C++, and it's Unity's tool to convert the intermediate language generated by your scripts into C++. And then it uses our build chain to build a native Linux binary that can run on our platform. So if your game code is compatible with IL2CPP, it will work on Stadia. If your game uses native plugins, keep in mind that our operating system is based on Linux. So any middleware you want to use, it must be compatible with our target environment. Most of the time, if you have an x86-64 build of a library and it works on Debian Linux, it will probably work on our platform. If you are a Unity plugin developer, also keep in mind that Stadia exclusively uses Vulkan for graphics. So our platform will support rendering plugins and shaders that target Vulkan. So that's all of the Unity-specific information I have to share right now. We'll have more details about Unity development on Stadia later this year, and I can't wait until you see the work that Nick, I think he's somewhere, Nick and his team are doing at Unity, and I definitely can't wait to see Stadia show up as a build target in the export window in Unity. That will be a very happy day for me. Now I'll go into our stack a bit and show you how cloud game development works on Stadia. We use the term instance to refer to a specialized virtual console in the cloud that runs your game. An instance is a virtual development space with no fixed development hardware. Your game is always going to be running on a virtual machine, whether you're in development, QA, cert, production. You reserve an instance, you deploy your build to an instance, and you stream from your instance. You're always playing a streamed version of your game. You actually will never run it locally. You always test it in streaming from when you develop all the way to production. The instance sends down video and audio to the client, as we said, and the input devices send input events upstream to the instance. And when you reserve an instance, you're reserving the hardware resources to run your game. Now, of course, that brings up the most common question: what are the hardware resources? What are the specs that your game gets to run on? As I mentioned, the hardware specification is not fixed. However, I'm going to show you the specs that our first gamers will be playing on at launch, and these are the specs that our launch title developers are optimizing against. So the CPU is a custom-built 2.7 gigahertz hyper-threaded x86 CPUs. It supports AVX2. AVX2 expands most integer commands to support 256 bits. In AVX, the original one, AVX1, they only supported that for floating point numbers. So AVX2 gives you 256-bit wide integer operations. The GPU is a custom AMD GPU, HBM2 memory, and you get 56 compute units capable of cranking out 10.7 teraflops. And that is a lot of floating point operations. I'm sure your games can make good use of every single flop. I look forward to seeing what developers do with this power. For RAM, you get 16 gigs total of RAM, and it gives you up to 484 gigabytes per second of performance. And then for storage, the SSD, you get cloud SSD performance, and I didn't pay much attention to this benefit at first until I started playing games on our platform. It makes a big difference. For example, I was really surprised when I was playing Doom 2016 for the first time on our platform, how quickly the worlds loaded compared to other platforms that I had played on. It was really surprising, and I see it benefiting lots of titles to have fast cloud SSD performance. So, and by the way, I will tell you, this is a great gaming machine. It also would make a heck of a crypto miner. And I swear I have not been using Google's data centers to mine crypto on our platform. I promise I have not been doing that. So this is the hardware that one Stadia instance gives you. But where does this hardware live? Where do you actually reserve an instance from? You reserve an instance from the Google Cloud. the hardware is hosted by us in our data center. Or you can host your own instances on-premise from hardware running within your studio that we call nodes. So when you receive an instance from our cloud, you will be running your game in our data center with the same exact hardware as the production instances that your users will be playing on. The clients running on the devices to the right connect to our instances on the cloud, and they stream games. So that's where you want to do all of your final tuning and debugging, because it is exactly reflective of what users will be playing on. Today, development is also done on nodes, which are hosted on-premise in-game studios. And development node instances are running on hardware that is representative of what runs on the cloud. So it's good enough for development and debugging, but it's not identical, so your tuning should be done on cloud. But they're perfectly good for development, testing, gameplay, debugging. This is a server development node. It's a rack-mount network appliance, and it lives in your studio's server room, or your studio's lab, or your studio's IT closet, or just somewhere cold and rack-mountable is where it lives. And it's like having a little slice of the Google Cloud right there in your studio to develop on. And when you develop using a node as opposed to the cloud, your assets do not leave the four walls of your studio. The game is streamed over LAN to your development PCs. Each server development node gives you 4 instances you can reserve. So 4 sets of that hardware spec I showed you before can stream simultaneously to 4 developer machines. So here we have 3 different machines reserved by, we have all 4 gamelets reserved here, streaming simultaneously to four workstations. There are different shapes of instances you can use just for development. For example, or I guess I should say for instance, if a development tool such as RenderDoc requires additional memory to run, you can reserve a high mem instance. Okay? So that gives you 32 gigs of total RAM instead of 16. We use the term shape, the shape of the instance. However, a high memory instance takes up 2 slots. So this node is serving 1 high mem instance and 2 normal instances. The developer with the high memory shape gets 32 gigs, but the node supports 1 less developer than before. On the bottom, we have our workstation development node. This is the last way you can reserve an instance. And this is a workstation that sits at your desk. It's in a desktop form factor. Just like before, your assets stay within the 4 walls of your studio, but this time the hardware lives at your desk. It's still a network appliance, and you still interact with a workstation instance the same as you interact with a server instance, but a workstation development node gives you 1 instance to develop on, and it can be any shape, so 1 instance of every shape. And these workstation development nodes are brand new. We're beginning to ship them to developers later this year. So now you have an instance reserved. How do you transfer your game onto it? I'll show you the easiest way first. If you want to have the most familiar console-like experience, you can just manually copy assets over to the instance and hit run. Here I have my instance mounted on my Windows machine, and I can use Windows Explorer to move files around. On the Linux box, mount/developer is the path that contains your assets. That's what I'm showing here. And /var/game is the scratch space that your game can write to, so you can pull your logs from /var/game. It also contains standard out and standard error are also there. If you don't want to copy assets over before running your game, you can serve them directly from your workstation. So you stream the assets, and the instance streams back your game. And depending on what you're doing, this may or may not be efficient, but you do have flexibility in whichever asset workflow is best for you. We also ship asset management tools with our SDK. Our CLI is another way we could have transferred that file and transfer assets back and forth. Another way is through our web UI, also the tool integrations I mentioned before. If you're not into command line, our web interface is called the Stadia Partner Portal. All Stadia developers can access this through their browser, manage your instances, your package, your users, your resources, all from our web UI. This is the play page, and it shows a list of builds that have been uploaded at my studio. Some of them are shared with me by my teammates. Some of them are my own builds. That third one definitely is not mine. At the top, you can see that I have an instance reserved, and I can use that instance to play one of my packages by pressing the play button. And that will that will mount the package, launch the game executable, and stream it to you right inside of the partner portal, as we saw before. You can now play the game, connect to debugger, use any other tools, and that URL that's in the address bar, now we have a button that copies it to the clipboard. So you could take a link and throw it to your producer, or throw it over to QA, or to anyone you've granted access to the game. You could throw a link up on Slack and have everyone try out your new multiplayer build. So I have one studio that's porting a game in Europe. The main game is developed on the US and the East Coast. Their publisher in the US is on the West Coast. And they send links across continents, and as long as someone's awake where they're sending it, they play the game. I also want to show you the command line interface that I mentioned a couple times. This is the help output, and you see a bunch of nouns. Our interface follows the same conventions as the Google Cloud Platform API, CLI, the Google Cloud Platform CLI. So if you've used those tools before, our CLI will feel familiar. It takes in a noun and a verb. So for example, instance reserve, or project list, or achievement create. These are all the nouns right now, and this tool is very well documented. So you pass a .h flag into any of these nouns, and it will show you usage. Another useful flag, I want to show you my favorite command first, SSH shell. You can open up an SSH session directly to your instance. Now, to develop on our platform, you don't have to do anything with Linux if you don't want to. But we want to give developers low-level access for those who want it, and it turns out some game developers do actually like Linux. And even though I could use Visual Studio or Notepad, I've been known to edit game data files using Vim from time to time. Another flag that our CLI tool supports is structured output. So for every command, if you pass in the structured flag, it outputs in JSON format. So this allows you to easily integrate our platform into your own tooling, build processes, QA, launchers, all of that stuff. And the command being run here is instance list. So the structured outputs gives us the data fields about the one instance we have reserved. Your automation can call this, parse the JSON, and be able to operate on this instance. This is what our partner resource center looks like. You visit it on the web to download the SDK, read and search the docs, and download samples. And if the style of this developer site looks familiar, that's because we stole it from Android and from Google Cloud Platform. Probably Google Maps too, I think, uses this. But Android and Google Cloud have been building this developer website infrastructure for over a decade. So we took it and we integrated it with our SDK, and the site updates upon each release. It contains documentation for both the C++ and C versions of our APIs. And this is one of the resources available to partners in our Stadia partner program, which, as a reminder, you can sign up for at stadia.dev. If this is interesting to you and you would like to try developing on our platform, you can apply right on there. So now we have time for a little bit of Q&A. I think I'm being joined by Nick Rapp. Hey, Nick. Nick is a lead engineer at Unity for desktop and web, and he knows a lot about Unity. I know a thing or two about Stadia, and this gentleman with the hat has a microphone for anyone who'd like to ask a question. Please don't be shy. Right here, front.
Hi.
Hi, Richard.
I was wondering if there's any support for touch input on mobile.
Touch input on mobile. Great question. We haven't announced the details of our mobile app at launch that it's going to use. So we haven't announced anything about that yet. As of right now, our input methods are gamepad, keyboard, and mouse, and that's what we're going to launch with. So that's all we've revealed about input so far. It's a good question because we haven't said anything about it. So yeah. There are no bad questions. Oh, another one, yeah. Follow up.
What sort of latency requirements do you have for the platform?
Yeah, great question. That's another one of the frequently asked questions for us. So players have to pass a connection test, just like with Project Stream, and there's a bar they have to hit. And that bar is, we haven't revealed concrete details about the latency bar and the bandwidth bar. And that's because we're still analyzing data from Project Stream. In fact, since we ran our Project Stream test, we had a third party measure our, it was Digital Foundry. Digital Foundry did an analysis on our latency, and it's already improved from what we had on Project Stream. and we're going to continue improving until launch, and that's why I have no data or no numbers to answer your question, because it's going to be different at launch as we improve every day. But obviously, as a cloud stream platform, latencies are a top #1 consideration. Everything is built around it, from the streamer, the encoder, the SDK, even to the controller. Everything is optimized for latency being most important. And again, you can try it out in our booth if you really want to feel what it feels like. Back there in the back corner. Hello.
How do you plan on dealing with network lag, especially as games get bigger and bigger? I don't know if you have a target size for what particularly is going to be running on these browsers, but just network lag in general, how do you plan on tackling that via real-time play?
Lag as opposed to latency like kind of what I just talked about. Well, I'll expand on what I just said and tell you one benefit. Conventionally, you have to deal with lag during multiplayer sessions and networking that way. On Stadia, you could have your entire multiplayer world running in one box, or they're all running right next to each other. So between players during multiplayer, network lag actually gets better, and developers have to do less to compensate for that. But as far as latency from the instances to the clients, kind of what I was just saying, we're looking at the data closely, we're improving all of the time, and yeah, it's very important to us. Cool. In the back there, it's like we're the least optimal path for you to pass the mic around.
How are you guys planning to support indies versus big studios? What's the rollout of hardware for that thing?
Yeah, great question. And again, it's a great question because we didn't announce anything there. But I'll say that Unity is a step in the right direction for sure for supporting indies, even though we haven't announced anything yet. So again, one of our focuses is democratizing game development, and we'll move forward with Unity, and perhaps that will open the door for really good indie stories later on. But right now, we haven't announced anything there. I've only ever been asked one bad question. You guys want to hear it? There's only one bad question. One time I gave this disclosure to a studio and they asked me, does it support offline play? It doesn't. No, it doesn't support offline play is the answer to that question. Anybody else? Don't be shy. Okay. You got anything you want to say, Nick?
No. Oh, sorry. No, other than the fact that myself and our cohorts at Google are over at the answer bar for another hour or so if you have follow-up questions that we didn't address here.
That's a great point. The answer bar is right over there, and we have Unity experts and Stadia experts there to answer your questions on a one-to-one basis if you want to talk more about latency or anything. All right, cool. Thank you, Nick. Thank you, everybody. Again, www.stadia.dev to sign up for our developer program, and thank you for listening.